This is A2 Pure Mathematics Algebraic Fractions. This is chapter 1, and today we're looking at algebraic long division. We have looked at this before in AS, and there are a number of different methods that you can use, so it might be that you want to go back to your AS notes and have a look at what you understood last year, but I am going to talk you through a couple of different methods during this video. The focus of it today is to do with fractions, so we are looking at where we have improper fractions. So that is where the degree of the polynomial on the numerator is higher or equal to the degree of the polynomial on the denominator. So when we're thinking about the degree of a polynomial, what you want to do is set your polynomial up so that your powers go in descending order, and we take the largest power. So this numerator here, this has degree 3. It's cubic, it's got degree 3. Because x cubed is stronger than the linear term, it's stronger than the x when we're substituting numbers in. Similarly, we've got the denominator here, so this is of degree 2 because the quadratic is the strongest term that we have in that denominator. Moving on to this fraction here, the numerator is quadratic, that's degree 2. The denominator is quadratic, that's degree 2. Both of these are improper fractions because here we've got a higher degree polynomial on the numerator, and here both numerators and denominators match in terms of the degree of the polynomial. So these would both fall under improper fractions. The way we're going to set it up is this here. So dividend is what you're dividing. So up here, this x cubed minus 5x plus 2 would be the dividend, and x squared minus 1 would be the divisor. Once we have done some work on it, the quotient is the whole part, and then hopefully you've heard of remainder before. You have seen this previously with numerical long division if you didn't use this, but some of you probably used it at AS in terms of doing algebraic long division, so you should have come across this notation before. Just a couple of really easy examples just to make sure we've got our head around what this means, because like I've said before, if you can apply it to number, then you're applying exactly the same thing to algebra. It should make it easier to understand. So when I do 7 divided by 3, I get 2 whole ones, so there's your quotient, and then I have a remainder of 1. We can write it like we've got here in yellow. We tend to write it like this. Similarly with this question here, I'd get 75 whole ones, my remainder is 7, so I've still got 7 over 20 in terms of the fraction, and I'd write it like this. If we're working with algebra, this x divides into both terms, so we've seen expressions like this at AS. We kind of looked at them particularly with differentiation, integration, and simplifying them down. So because we've just got a single term on the denominator, it can just divide into each of those. So I get x plus 1 over x. Now at this point, we can't get rid of that plus sign because we know that in algebra, if I put them next to each other, then what I will end up with is x times 1 over x. So if I follow this notation, that then would just equal 1, which is not what we're looking for. So we need to leave that plus in there when we're working in this format. So when we're looking at having this, we need to make sure we've got the plus in there, and that's how we're going to be setting these questions up. So we're going to look at doing this question 3 ways. You can pick your favourite method, and then you just need to practice it so that it comes naturally. Again, like all the algebra topics that we do, it's something that we need to work on. So first of all, we have this method that hopefully we've seen a number of times before. Some of you might not have looked at doing long division like this at AS level, in which case you might want to skip on to the alternative method, which is more the inspection way of doing it. But I just thought I'd mention this briefly. I'm only going to do this method once because actually I think the other method is more efficient for this topic. So the first thing to notice is that I need to put this into order, so order of the powers. So I've gone x cubed and then I've taken the x squared term second. What you're going to focus on is this 2x. So when you're doing the division and you're using it this way, we're taking that 2x there and we're dividing the first term, so 8x cubed by 2x. So 8x cubed divided by 2x gives me 4x squared. I then take that term and I multiply it by the whole of this bracket, and that is to see what I've got. So at the moment I know that I've got 4x squared, so then if I'm reversing the division, so that will be multiplying, that would give me 8x cubed plus 4x squared, and I'm going to subtract that away from the original polynomial to see what I am left with. So when I take it away, this term here should disappear. If you're doing this right, you should keep eliminating this term that's furthest left in your working out. So minus 6x squared, take away 4x squared, just watch this minus sign here, gives me minus 10x squared, and then we repeat. So once you've got your head around that bit of the process, it might be that you want to watch this a couple of times if you can't quite remember it from last year, then you just repeat the same process. So we bring this term down, so I want to, this polynomial still hasn't been touched at this side, so that x is coming down, and then I want to start again. So I'm going to divide by the 2x into the term that is furthest left, because that has the highest power. So minus 10x squared divided by 2x gives me minus 5x. We take this and multiply it by this bracket here, so that we can see what we've got. And when I expand that out, I expect this term on the left to go, I am going to subtract. X take away minus 5x gives me 6x, and then we repeat. So we're going to do 6x divided by 2x, which is going to give me 3. Sorry, we need to bring that plus 5 down. So I get that's 3 there. Then I'm going to expand that out. So I get 6x plus 3, and then I need to subtract. So the reason we bring these values down is because they're sat there up at the top, it's a little bit hard to see, so they're just coming down there just so that they're part of the subtraction. And when I do the subtraction, I've got 2 divided by 2x. 2x can't go into that because we've got an algebraic term on the denominator, so this is the point where we would stop, and that 2 is our remainder. So we know we have got this is the whole part here, so this is the quotient, this is the remainder, and we would divide it by the divisor, which we've got there. So putting all that together gives me that answer there. So that would be how it would look. Now, quite often in the exam, they set this up as an identity and ask you to find the different values. So I'm going to go through it that way. So we're going to look at doing it this way. So if we were asked to do this cubic here divided by 2x plus 1, it's exactly the same question. So hopefully, having just looked at where this has come from, it might help you try and understand this method, because it should be a little bit quicker. However, if they don't give you this identity, let's just talk about where this has come from. So what I'm doing is I'm looking at this term here, so this is cubic, and I'm saying if I divide, I'm not interested in the numbers at this point, but if I divide a cubic by x, so by a power 1, by a linear term, so x cubed divided by x is quadratic, so it's x squared. And then I go x squared divided by x would give me x, and an x divided by an x would give me a number. At that point, I know that that's where the division would stop. So it's almost the same as doing this, but just without thinking about the numbers. So you're just going through and saying, where would I need to stop? So I wouldn't be able to continue past that point. So that would give me, this here is a constant term, so that's why I've ended up with a constant term as the remainder. And what you want to do when you're practicing this is try to get to the position where you can decide what the remainder looks like and what this quotient looks like, so that you can set up your own identity if it isn't given to you in the examination. Now what we're going to do is we're going to multiply through by 2x plus 1, and that's going to give me this here. So I've still got this numerator as stayed, and then we've got ax squared plus bx plus c times the 2x plus 1, and then this fraction here, when I times it by 2x plus 1, I just get the plus d. Okay, so let's just have a think about how we can find d, which is the remainder. So something that you should have seen before. If I substitute x equals minus a half in, that is coming by looking at this divisor and putting it equal to 0. and letting x equal -1/2 in order to do that. If I substitute that into this polynomial, that should give me the remainder. And the reason why that is working is because if I substitute it into the right hand side, remember these two things I'm claiming are equivalent. So whatever I do, whatever value I put into the left hand side, I would get exactly the same value when I put it into the right hand side. So if I substitute -1/2 into here, because that is equal to 0, it will cancel all of that section out there, which will just leave me with the remainder, which is d. And you should recognise that as the factor remainder theorem that we looked at as part of AS. So I know from here that d is equal to 2. So what I'm going to do is I'm going to substitute that in. Now, looking at this section here, we've got ax squared and 2x. I'm going to go through this question for a third time on the next slide, so you might find that a little bit easier, but this is just for those of you that can spot how to do this. You should recognise this as inspection. So when I'm looking at this, the only place that I can get x cubed from is by multiplying those two terms together. Therefore, that tells me that a needs to be 4. Continuing, if I look at the constant term, so the only place I'm going to get a constant term from here is the c times 1, and I've also got a +2 to think about. So c plus 2 has got to equal 5. That tells me that that c needs to be 3. The only thing I've left to find now is b, and I can do that by using either the quadratic term here or using the linear term here. So if I'm looking at the quadratic, I can get quadratic from 4x squared times the 1 and bx times 2x. They're the two places a quadratic term will come from. And because I know that that's 4, so I've already got a 4x squared, and then this will give me 2b, then I can work out that I'm getting a -5 for that term there. And there we have it. Once you get down to that point, we can look back up at this line here and then go back to the original way of writing it down and saying, well, that is going to give me this when I expand it out. Now, if that alternative method isn't something that you can follow, because that is quite quick and it really you need to understand factorising and expanding mentally in order to be able to do it that way, let's look at using exactly the same method but by expanding it out. So I'm going to talk you through how to do this now again, and then you've got 3 different ways of thinking about this. It might be that you need to pause the video and kind of just really have a think about which one you're going to use and then practice it. It might be that you decide to practice all 3 and find which one you're more comfortable with. If you have found one that you're happy with, feel free to move ahead and look at the second part of example 1.2.1. So here we go again. It is the same question that we've just looked at, but we're going to do more of a written method with it here. So it might be that you try and practice it this way, just because it'll give you something to work with, and then you can go back to the previous method. I would advise this over the first method of long division if you can get your head around it, because I think it will save you time in an exam situation. So what we're going to do is start off by multiplying through by the 2x, and then I need to expand this bracket here. So you're just going to expand it out. So what you might want to do now is pause the video and just check that you understand where that expansion has come from, and then I'm going to colour code it. So what we've got here is the x cubed sections all in green and the quadratic sections all in pink, etc. So again, just check that you understand that expansion, check that you understand that colour coding, because what this does now is I can compare coefficients. Remember, a coefficient is the number that falls before the algebraic term. So the coefficient of x squared here is -6. So I'm going to compare coefficients on both sides and set up little equations to solve, which is a little bit easier than the previous method where we just look like we're guessing what the values are. So if we start with the x cubed term, I've got 8 here and 2a here, so I'm going to equate them, and then when I solve that I get a is equal to 4. Moving on to the quadratic term, so I've got a -6 here, and then I've got an a and a 2b here. Now it's almost like factorising it, so if we were to write it as x squared and then a plus 2b, the a plus 2b then becomes the coefficient of x squared, because that's the number that we've got, that's the term that we've got. So that's what we're doing here. We don't need to worry about the x squared because that's the variable. So then what I've got is minus 6 is equal to a plus 2b. And then because I know that a is equal to 4, I can substitute that into here and take it off. Dividing by 2 is giving me b is equal to minus 5. Moving on to the linear term. So I've got plus x here, and then I've got a b and 2c. So when I equate those, I get this equation here. We know that b is equal to minus 5. Substitute it in and add it across is giving me 2c is equal to 6. Solving, we've got c is equal to 3. And then the linear term, I've got 5 and c plus d over here, filtering the 3 through. So we get 3 here, subtract it off, d is equal to 2. Okay. Now, the problem with this method is that if you make a mistake up here, so if we get the 4 wrong, then we are going to get the minus 5, the 3 and the 2 wrong. So we do need to be careful when we're using this method, because we can throw the whole question away just by making a small mistake up here. So there are a couple of things that you can do. One of them is to check your value. So this we've just talked about using the remainder theorem. So check that d is equal to 2 using the factor remainder theorem. If you get something different, then you know you've made a mistake somewhere in here, and it's probably just a minus sign. That tends to be the mistake. So just check your minus signs, maybe pick up your calculator and just check a little some of your calculations when you've been solving them, because that tends to be where people make the mistakes. Your brain's so busy concentrating on the harder algebra that you forget some of the basic stuff. Alternatively, what you could do is, well, we take this value from here, so we can substitute all of those into here to give me the answer. Now what I'm claiming is that this is exactly the same expression as this one up here. So if I substitute a value for x in here and then substitute a value for x in here, as if I'm getting the same value, then I know that I've got this correct. So that's another way that we can test to check that we've got the right answer. So here is a question for you to have a go at. So see if you can get to the end of it and then maybe play the video and check your answer. If you think that you're going to struggle a little bit, maybe just take this a step at a time. So have a go at writing it down. Remember, you learn best by making mistakes. So have a go at writing one step down, then play and see how far you can get. So I'll talk you through setting up the identity. So what we've got is we've got a linear term here. So I'm looking at doing x cubed divided by the linear term will give me quadratic. The quadratic divided by the linear term is going to give me x, so it's going to give me a linear term. And then because these are in slightly different order, it will be this one next, which would give me the constant. So we do end up with a similar setup as we had on the previous question. Please make sure that you understand exactly where this has all come from. So step 1 is to multiply through by this x plus 3. So you're going to multiply through, and then you need to expand this bracket out. So it's the same as the last question. I've got it colour coded in the same way. It may be organised slightly differently, but the method should be exactly the same. So starting with the cubics, we've got a is equal to 1. Filtering that 1 through into the quadratics. So we've got 6 is equal to 3a plus b. b is equal to 3. Looking at the 13 and the 3b and the c for the linear term, leads me to c is equal to 4. And then for the constant term at the end, we've got 12 is equal to 3c plus d, which leads me to d is equal to 0. So in fact, x plus 3 is a factor of this cubic here. So that's what that is telling us. And it's quite easy to check that that is true using the factor theorem. So check that d is equal to 0. We just substitute. So we take this from here, substitute x equals minus 3 into the cubic, and we do end up with a remainder of 0, so that matches. And therefore our answer is just the quadratic section, because we've cancelled out that bit there. Moving on to the next question. So this is very, very similar. I'll just slow down a little bit for the beginning section. Again, I'm going to set up the identity, but this time I'm looking at dividing by a quadratic. It's still improper because I've got x cubed here and I've got x squared here. So this degree is 3, which is bigger than 2. So when I divide it through, x cubed divided by x squared is linear. So I know that I'm going to have some term with x. Oops, it didn't want to write that. And then when I do 3x squared divided by x squared, that's going to give me some sort of constant term. So we've got something x plus constant term, but then I can't go any further, so that would be the cut-off point there. So then I know the remainder section needs to be of the form x plus constant again. So that is going to lead me to here. So I've got ax plus b, and then my remainder is of the form cx plus d. And then from there, it is a similar process. It will just look slightly different in the equations. So we multiply through by x squared plus 2, so take that divisor all the way through, and then expand. So when we've expanded here, this has ended up being in a slightly different order. So it might be that you want to reorganise this now, so that you put the constant terms together and the x terms together, so that we go in the same order of this. So a is equal to 2, the only place I can get cubic from. Then we have b is equal to 3, because that's the only place I can get a quadratic from. When we look at the linear term, so I've got minus 4 is equal to 2a plus c. Substituting a equals 2 into there and subtracting gives me c is equal to minus 8. So we are using a to find c, whereas I think on the last examples you will be using b to find c. And then continuing, we've got the constant term, so we've got 1 is equal to 2b plus d, but b is equal to 3. So I'm doing 1 take away 6 to get d. And then I can substitute it in. Just watch this here. So I've got minus 8, minus 5. That minus sign, it's a lot neater if I sit it here. And I did talk about this in one of the previous videos. So I'm going to write it like that. Now, because we can't use the remainder theorem at this point in order to check this remainder, what we can do is substitute a number into here and substitute a number into here, and just like when you're doing 7 over 2 and you're getting 3.5, they are the same value, they represent the same thing. The same thing should happen here. Okay. Have a go at this one. So you've got cubic divided by quadratic just the same way as we have done. So set up your identity and see if you can work through this. So again, when I do cubic and quadratic divided by quadratic, this is going to be my cutoff. So my remainder is going to look like that. So that's my identity, which is the same as the one I've just used on the last example. Multiplying through by the quadratic and expanding, matching the coefficients. So a is equal to 2, 9 is equal to 3a plus b. Substituting the 2 in, 9 take 6 is equal to 3, so b is 3. Looking at the linear term, so we've got 5 is equal to a plus 3b plus c. Substituting a equals 2 and b equals 3 into there gives me c is equal to minus 6. Looking at the constant term, so we've got minus 6 is equal to b plus d, b is equal to 3, and therefore we end up with d is equal to minus 9. Putting that into the format, because I've got minus 6, minus 9, I've put that minus sign in front of the fraction again. Remember, that just affects the numerator and not the denominator. And there we have it. That's the answer to that question. It is worth being able to write it out just in case you get stuck. So even if you're trying to do inspection, please make sure you've got another method, whether you're using long division. Some people like to use the grid method, which I haven't mentioned here, and there are lots of other ways that you can do algebraic long division. I just quite like this one because we have seen a lot of our exam questions being set up with this identity, so I think it's quite a good way to progress, but having more than one method is always useful anyway, so get practicing.